All right, here we go. So now we're going to talk about greatest common factors and factoring polynomials. So we're going to do this in steps. And the first step you always want to do whenever you're factoring a polynomial is to look at or look for a greatest common factor. So just like with factoring numbers, right? When we factor numbers, like let's say 8 minus 24, right? And we want to factor this out, and we want to, just like with numbers, if we want the greatest common factor, we want the number that will, the largest number that will divide both numbers. So in this case, the largest number that will divide 8 and 24 is 8. And so we can rewrite this by factoring out the 8 and writing this as 1 minus 3, right? So 8 times the quantity 1 minus 3, right? And you've probably seen this before, like way back in grade school or whatever, when we were dealing with, distributive property in factoring. Well, the same thing applies to polynomials. Remember, all of these variables just represent numbers, right? We just don't know what they are, or they change, right? So, where's my... hold on a second, Okay. So now, if we want to look at this polynomial, right? And so we see that it's addition and subtraction. What we're wanting to do is we want the largest value, right, or variable that we can factor out, right? So what's the largest number, right? The coefficients, right? So we want the largest coefficient that will divide all three coefficients. And we want the largest value of x, the largest exponent of x that will divide out of the x's, right? So what we're going to do is we first look at the coefficients and we say, okay, what's the largest number that will divide all three, right? And so in this case, it's going to be 6. So when we're looking at the greatest common factor, we're looking at the largest number that will divide all of the coefficients. So that's going to be 6 in this case. And then we want the largest exponent of x that will divide x, right? So here, if you look at this, this is x to the 5th, but this means that there's 5 times x, right? So there's x times x times x 5 times. Here we've got 4 x's that are multiplied together. Here we've got 3 x's that are multiplied together. So how many x's, what's the largest number of x's that we can divide out of all of these x's? And in that case, it's going to be 3. We're limited by the exponent 3. We can only factor out a maximum of 3 x's here, 3 x's here, 3 x's here. So that means we're going to put x cubed. So that means the greatest common factor is x cubed, right? And so what we want to do is now we're going to factor out by saying, okay, we're going to factor out the x times, or excuse me, the 6 times x cubed, right? And so we need to figure out what's left over, right? So when we factor out the 6 from the 12, that's going to leave us 2, because remember the distributive property, we've got to get back to where we started. So 6 times 2 equals 12. Now, x cubed times what equals x to the 5th? And that's going to be x squared. Plus, now we're going to say 6 times what equals 18? That's going to be 3. And then x cubed times what equals x to the 4th? That's going to be x. And then we have minus, and then finally we have 6 times 4 will give us 24. And then x cubed times 1, right, is going to give us x cubed. So we don't need to put the 1 here, right? So we can just ignore that because 4 times 1 is still 4. And so now this is what we mean by factored, okay? And anytime you factor something, you should be able to use the distributive property to go back to the original problem, okay? All right, that's it. So we'll do a couple of examples.